Molecule number 5 is now going to get converted to molecule number 6. In doing so, we're going to produce some energy. We're going to have another carrier molecule called FAD come in here, pick up its cargo, 2 high energy electrons and a proton, and get converted or reduced to FADH2. Molecule number 6 is now going to get converted to molecule number 7. No energy produced there. However, molecule number 7, when it gets converted to molecule number 8, we are going to pick up some more energy. And NAD plus is going to be reduced to an NADH. However, no carbon dioxide is going to be produced in this step. Now think about this. We have 2 carbons in the form of acetyl-CoA coming into our Krebs cycle. And you can see here we lose a carbon dioxide, so we lost 1 carbon there. Here we lose another carbon dioxide, so we've lost another carbon there. So 2 carbons in, 2 carbons out. We also produce quite a bit of energy here. Remember, we have 2 acetyl-CoAs coming into this cycle, so there's going to be 2 turns of this cycle. So I produce an NADH, 1, 2, 3. And because I have 2 turns of the cycle, 3 plus another turn, 3 more, ultimately I'm going to get 6 NADHs. Same thing goes with ATP. I produce 1 ATP here, but when the other acetyl-CoA comes in, I'll produce another ATP for a total of 2 ATP. FAD goes to FADH2. I've got 1 of those, and when the other acetyl-CoA comes into my cycle, I'll produce ultimately 2 FADH2s. Now, what we want to do at this point is tally up all our energy. So let's go ahead and tally up our energy. We're going to start with glycolysis. We produced 4 ATP with glycolysis, 2 NADHs, and no FADH2s. Now we know that FADH is a carrier molecule and it's carrying enough energy to produce 3 ATP. So I'm going to write times 3 equals 6. 2 NADHs, each capable of producing 3 ATP for a total of 6 ATP. Now when we add these numbers up, 4 plus 6, the total amount of ATP that we'll ultimately produce, when this is all said and done, is going to be 10 ATP. If we do the same thing for the gateway, we find out we produce 2 NADHs, each capable of giving us 3 ATP, so 2 times 3 equals 6, and we're going to have a total of 6 ATP. And Krebs cycle is going to give us 2 ATP immediately, 6 NADHs, each capable of giving us 3 ATP for a total of 18, 2 FADH2s, each FADH2 is capable of producing 2 ATP for a total of 4. So let's add up our numbers. 2 plus 18 is 20, plus 4 more is 24. Let's add these all up and call it our gross ATP. So 24 plus 6 is 30, plus 10 more is 40. So 40 ATP gross. However, that's not my profit. If you recall, I had used 2 ATP to get glycolysis going, and then 2 more ATP to transport each pyruvate molecule from the cytoplasm into the mitochondrial matrix. So I'm going to go ahead and keep track of that. Minus 2 ATP for glycolysis, and minus 2 more ATP for active transport. I'm then going to add everything up. 40 minus 2 more is 36 ATP. And I'm going to call this my net. That's my profit right there. I have a profit of 36 ATP, which is pretty good.